This is mathheals.com. You can find more links to YouTube videos under here if you wish, under class information or any of the other links. Let's take a look at dividing monomials, the quotient rule, and integer exponents. Now this covers some new properties, so let's kind of review some of our old ones, and we'll build upon them. Remember, if you have x to a power times x to a power, like x to the m times x to the n, you add the exponents. So that becomes x to the m plus n. If you have x to a power, then you raise it into another power. You've got to multiply the exponents together. I'll write our note up here in a minute, but we have some new ones here. Anything to the 0 power is always equal to 1. So anything to the 0 power is always equal to 1. Why is that? Well, think of a simple number example here. We have 3 to the first is 3. 3 squared is 9. 3 to the third is 27. And 3 to the fourth is 81. If I go up on this, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Going in reverse, 81 divided by 3 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1. By definition, anything to 0 power is always 1. Now if you have a I'm going to put a couple notes up here to help us work some of these problems. But if you have a negative x exponent, like you have 1 over x to the negative 2, you take the part that's to a negative exponent opposite of where it's at in the fraction. So it's x to the negative 2, I take up on top, and it becomes x to the positive 2. And then you put a placeholder of 1 here. Now I'm actually putting numbers here so you can see the examples, but let's say I had x to the negative 4. We want to move it opposite of where it's at in the fraction, but that's not in fraction form. So we'd have to put over 1 to begin with. And then I take the x to the negative 4 downstairs, and it becomes x to the positive 4. So again, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. Now if we have a fraction, whatever the fraction might look like, to a negative exponent, you can flip the entire fraction, and then the sign of the exponent becomes positive. So the x over y becomes y over x, and then it becomes positive. Now we had a note here that said if everything inside of parentheses a parentheses is either multiplication or division, so it's either multiplication or division, and you are taking the parentheses to a power, then you can take everything inside the parentheses to the power. So if everything inside parentheses is either multiplication or division, and you're taking the parentheses to a power, more and more I talk like Yoda and write like Yoda, and you're taking if everything inside of parentheses is either multiplication or division, you're taking the parentheses to a power, then you take everything inside the parentheses to the power. What in the world does that mean? We have 3x y squared and raise it to the third power. Now everything inside the parentheses is either multiplication or division. 3 times x times y squared. And you're taking the parentheses to a power, taking the third power. They should have called this like the distributive property of exponents. But it says then you can take everything inside the parentheses to that power. So we're going to take the 3 to that power, the x to that power, and the y squared to that power. So this would be 3 to the third power, x to the third power, and the y squared to the third power. And then you could go down from there. So that's what that's referring to. Now we have a note also for division. This is when you got a problem that looks like this. X squared over x to the fifth. The note on this says, if you, and I'll write this in terms of x's, if you have x to a power over x to a power, then subtract the smaller exponent from larger. So subtract the smaller exponent from larger, and you have x to that power where the larger exponent was. So where the larger exponent was. Well, what does that mean? Here we got x squared over x to the fifth. This is subtract a smaller exponent from a larger one. So 5 minus 2 gives us 3. And we have x to this power where the larger exponent was. Larger exponent was downstairs, so we're going to have x to the third power down there. Now with a fraction, if everything disappears, you're always left the invisible 1 there. Well, you always left the 1, which becomes visible, I guess I should say. I better go to bed. But anyway, we'll see more of those. Let's look at our first problem here. Now they got a different rule in the book, and I don't like it. I like my own. Mine's easier for students to use, in my opinion. Okay. Now numbers, you treat just like normal. So looking at 16 and 12, if you can divide both of them by the same number, do so. They're both divisible by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. So we're going to have 4 over 3. Now this x down here is like x to the first power. So we got x to a power over x to a power. We're going to subtract the smaller exponent from the larger one. So we got 5 minus 1 gives us 4. And we're going to have x to the fourth where our larger exponent was, which was on top. So we'll put an x to the fourth here. And that's our answer. Now let's look at another one. Got 12x squared over 9x to the 6. First thing, let's look at the numbers. 12 and 9 are both divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Now we have x squared over x to the 6. So you got x to a power over x to a power. You subtract the smaller exponent from the larger one. 6 minus 2 gives you 4. And you're going to have x to that power where your larger exponent was, which is downstairs. So I have an x to the fourth there. Let's look at this one. Negative 50 x to the third y to the 10th over 10 x to the 8th y squared. Well, first let's talk about the numbers. 50 and 10 both divisible by 10. Negative 50 divided by 10 is negative 5. 10 divided by 10 is 1. Now for the x's. I got x to a power over x to a power. So subtract the smaller exponent from the larger one. 8 minus 3 gives us 5. And we're going to have x to that power where our larger exponent was, which was downstairs. Now y to the 10th over y squared. You got y to a power over y to a power. Subtract a smaller exponent from a larger one. 10 minus 2 gives us 8. And we're going to have y to that power where our larger exponent was, which was on top. And the 1 disappears down below. So we got negative 5y to the 8th over x to the 5th. Let's take a look at our next one here. Negative x squared y to the 4th to the 3rd power. First off, we've talked about this before. When you got a negative inside to an odd power, well, then it automatically becomes negative. So that part just stays negative. And if everything inside your parentheses is either multiplication or division, here we got x squared divided by y to the 4th. Well, you can take everything to this power. So we're going to take x squared to the 3rd power, and we'll take y to the 4th to the 3rd power. Well, remember when you raise an exponent to another exponent, you multiply them together. 2 times 3 is 6. So we got x is 6. And down here, you're raising 4 to the 3rd power. That gives 4 times 3 gives us 12. So our answer is negative x to the 6 over y to the 12th. Okay, let's look at this one. We got 3 m to the 3rd n over q to the 5th. And you're raising it to the 4th power. Okay, remember what I said. If everything inside your parentheses is multiplication and division, well, we got 3 times m to the 3rd times n divided by q to the 5th. Everything's multiplication and division. And you're raising the parentheses to a power, you can take everything to that power. So we'll have 3 to the 4th power, m to the 3rd power to the 4th power, n to the 4th power, and q to the 5th to the 4th power. Well, 3 to the 4th power. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. When you're raising an exponent to another exponent, you multiply them together. 3 times 4 is 12, so we got m to the 12th. And this is just n 4th. And this would be q to the 20th. 5 times 4. And that's our answer. Now here we got negative 2 to the 0, and ignore the instructions. Really, all go back to those basic properties I put up at the very first. If you remember how an exponent works, an exponent only affects what's to its immediate left unless there's parentheses. If there's parentheses, it affects everything inside the parentheses. So this right here, the negative has nothing to do with that exponent. So negative just carries down. And remember, anything in the 0 power is 1. So this becomes negative 1. Now I'll compare that to this example. Negative 2 to the 0 power. Your exponent only affects what's to its immediate left unless there's parentheses, and it affects everything inside the parentheses. So the 0 power is affecting everything inside. So all this just becomes 1. Let's look at this one. We got negative 3x to the negative 4. Now we talked about the negative exponent before. We said we can't have them. That was in our properties at the very beginning. We got rid of them, didn't we? So that's what we're going to do here. Now, in order to get rid of it, you have to take it opposite where it's at in a fraction. So I'm going to need to create a fraction. I'll put it over 1. So if you don't already have a fraction, you can easily create one like that. Now the part with the negative exponent, we're going to move it opposite of where it's at in a fraction, and then the sign of the exponent will change. So we'll take the x to negative 4 downstairs and becomes x to the positive 4. Now the 1 just disappears because 1 times x to the 4th is just x to the 4th. And that's our answer. Here we got 3 to the negative 2 minus 2 to the negative 3. Almost always your very first step is to get rid of negative exponents. Well, I need to put these in fraction form, so I'll put this over 1, and I'll put this one over 1. And we get rid of the negative exponent by moving it opposite of where it's at in a fraction. So the 3 to the negative 2 I'll take downstairs, and 2 to the negative 3 I'll take downstairs. So take them both to the denominator. So this becomes 1 over 3 squared minus 1 over 2 to the third. Well, 3 squared is 9 minus 1 over 2 to the third is 8. Now to combine these two fractions together, we have to get a common denominator, which would be 72. Now in our first fraction, we multiply the bottom part by 8 to get that new denominator, so we have to multiply the top part by 8. On our second fraction, we multiply the bottom part by 9 to get that new denominator, so we have to multiply the top part by 9. And now that they have the same denominator, I can combine them together. 8 minus 9 gives us negative 1 over 72. And that's our answer. Let's take a look at this one. Got negative 2 over 4x to the third to the negative 2 power. Now we had a property I wrote up at the very beginning, said if you have a fraction to a negative power, you can flip the fraction. So this becomes 4x to the third over negative 2 to the positive 2 power. Well, I can do a little bit of simplifying in here. 4 divided by negative 2 gives us negative 2, and the x to the third remains. Now, if everything inside your parentheses is either multiplication or division, you can take everything to that power. It's kind of like a distributive property of exponents. You're going to take the negative 2 to the second power and the x to the third to the second power. But speaking of the negative, remember a negative raised to an even power just always becomes positive. So we don't even have to worry about the negative. So we got 2 squared and we got x to the third squared. 2 squared is 4. And when you raise one exponent to another exponent, again you multiply them together. 3 times 2 gives us 6. So we got 4x is 6. Let's look at this one. Got 5 over x to the negative 4. We always want to get rid of negative exponents, so I'm going to take the x to negative 4. I'm going to move it upstairs. When you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the x to negative 4 becomes x to the positive 4. Now there's nothing left down there, so I'll put a 1 as a placeholder. And then 5x to the fourth over 1 just gives you 5x to the fourth. Let's take a look at this one. We got 3 over 5x squared to the negative 3 power. Well, this time we don't want any negative exponents, so I'm going to take this whole thing and move it up on top. So this becomes 3 times 5x squared to the positive 3 over 1. Now notice any of the signs of the exponents of what's inside the parentheses don't change. It remains exactly as is. Just the negative 3 became a positive 3. Distributive, again, I should call it distributive property of exponents. If everything inside your parentheses is multiplication or division, and you're raising it to a power, you can take everything to that power. So I'll take 5 to the third and x squared to the third. So that gives us 5 to the third and x squared to the third. How did I know to do that? I'm looking at this, it's like, why didn't you multiply the 3 through first? Think back to your order of operations. Please excuse my dear Aunt Sally. Do what's inside the parentheses first. There was nothing. Excuse exponents. Well, that's why we took the negative 3 up there to make it positive, and that's why we carrying that through first. And now multiplication division. Well, actually, I guess I got a little bit more exponents, don't I? 5 to the third is 5 times 5 is 25, times another 5 is 125. And then, when you're raising one exponent to another exponent, you multiply them together. 2 times 3 gives you 6. And now we can multiply. 3 times 125 is 375, x is 6. And that's our answer. Let me start a new page. And let's look at this one. So we got 2/15, x squared, y to the negative 4, and then negative 5/8, x to the negative 4, y to the 7th. Now, personally, I like to get rid of the negative exponents as fast as I can, because negatives just cause people headaches. Well, here we have a fraction, and when you got multiplication with these right next to it, you can just put them up on top. So that's like x squared, y to the negative 4. Why is that? Well, I could put these over 1, and then if I multiplied them together, I'd get this. Same thing here. I'm going to have negative 5, x to the negative 4, y to the 7th, over 8. Well, we're going to get rid of the negative exponents. So I'm going to take this y to the negative 4 and move it downstairs. I'll take this x to the negative 4 and move it down below. Now the negative 5 there doesn't bother us. It's negative exponents we're trying to get rid of. So this becomes 2x squared over 15y to the 4th. And this one becomes negative 5 y to the 7th over 8 x to the 4th. I can do a little bit of simplifying. Here I got 2 and here I got 8. Those are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So 1 times x squared is just x squared. So we got x squared over 15y to the 4th. And then negative 5y to the 7th over 4x to the 4th. Negative 5 and 15. They're both divisible by 5. 15 divided by 5 is 3. Negative 5 divided by 5 is negative 1. So this becomes x squared over 3y to the 4th. And then negative y to the 7th. Negative 1 times y to the 7th. And then 4x to the 4th. Well, let's go ahead and multiply the top parts together. So positive times a negative is negative. And then I'll put the x squared and y to the 7th just next to each other in alphabetical order. Down below, 3 times 4 is 12. And I'll put the x first and then the y second. Now you could have simplified them up here, but I wanted to go ahead and put them in a single fraction and do it. Number-wise, the negative's up here. 12 is down here. Okay, let's look at our x's. X squared and x to the 4th. You got x to a power over x to a power. You're going to subtract the smaller exponent from the larger one. 4 minus 2 gives you 2, and you have x to that power where your larger exponent was, which was downstairs. Now the y's. I got y to the 7th over y to the 4th. Well, again, we got y to a power over y to a power. Subtract the smaller exponent from the larger one. 7 minus 4 is 3, and we have y to that power where the larger exponent was, which was on top. And that would be our answer. Some of these problems start out looking kind of hideous, but you just take it step by step, thinking what you want to get rid of, what you want to do. You know, get rid of negative exponents, combine together x's and y's and things that are alike. Here we got 20x squared y to the negative 3 over 30x to the negative 4 y to the negative 12. Okay. Place to start. We don't want any negative exponents. So this y to the negative 3, I'm going to take downstairs, take it to the denominator. This y to the negative 12 is going to go up on top. this x to the negative 4 will go up on top. So we're taking everything with a negative exponent opposite of where it's at in the fraction. We'll simplify those numbers in the next step. Okay, so the x squared stays up here. I take the x to the negative 4 up on top, it becomes x to the positive 4. I take the y to the negative 12 up on top and becomes y to the positive 12. And I take y to the negative 3 downstairs and becomes y to the positive 3. When you move anything opposite of where it's at in a fraction, again, the sign of the exponent changes. Now 20 over 30, they're both divisible by 10. 20 divided by 10 is 2. 30 divided by 10 is 3. Now x squared times x to the 4th, you're going to add the exponents. 2 plus 4 gives us 6. And here we have y to a power over y to a power. Well, we're going to subtract the smaller exponent from the larger one. 12 minus 3 gives us 9. And we're going to have y to the 9th where our larger exponent was, which was on top. So our answer is 2x to the 6, y to the 9th over 3. And I guess I got enough room for this next problem. So let me do 15 here. And we got 2x to the 4th, y to the negative 2. And then we have 3x, y to the negative 3, over y to the negative 5. And then all that raised to the second power. Okay, a lot of different things going on here. Well, let's think it through. Please excuse my dear Aunt Sally. Dear Aunt Sally tells me to do what's inside the parentheses first. So let's start there. Well, right away, inside the parentheses, I notice I got negative exponents. I don't like those. And you move those opposite of where they are in fraction form. Well, this first one's not in fraction form. So I'm going to take the 2x to the 4th, y to the negative 2, put it over 1. Now this second one, I can go ahead and move some things here. Here's a y to the negative 3. I'm going to take that downstairs. And here's a y to the negative 5. I'm going to take that up on top. So it becomes 3x, y to the 5th, over y to the 3rd. Anytime you take anything opposite of where it's at in a fraction, the sign of the exponent changes. Okay, please excuse my dear Aunt Sally. I'm still doing what's inside of the parentheses. And my first parentheses here, I got a negative exponent. So I'm going to take that y to the negative 2 downstairs. So we got 2x to the 4th over y squared. And our second set of parentheses here. We got 3, we got x. We got y to a power over y to a power. Remember, you subtract a smaller exponent from a larger one. 5 minus 3 gives you 2, and you have y to that power where your larger exponent was, which was on top, over 1. Now, please excuse my dear Aunt Sally. Nothing really left to do inside the parentheses. I'm going to leave that over 1, by the way, because I know eventually I'll be multiplying fractions together, and it's beneficial if they're both fractions. Please excuse exponents. Well, we got exponents all over the place, but can't do anything with the 4th, can't do anything with second power and the y. But here, if everything inside your parentheses is either multiplication or division, notice here I got 3 times x times y squared divided by 1. So if everything's multiplication division, you can take everything to that power. So let's do that. So we got 2x to the 4th over y squared, and we're going to have 3 squared, x squared, y squared to the second power, and 1 squared. Okay, so we have 2x to the 4th over y squared. Now 3 squared is 9. That's x squared. Now y squared to the second power, you raise an exponent to another exponent, you multiply them together, so that gives us y to the 4th. And 1 squared is 1. Okay, please excuse. No exponents left to do. My dear, multiplication and division. Well, let's go ahead and multiply the top parts together and bottom parts together. 2 times 9 is 18. X to the 4th times x squared gives us x to the 6th. You add the exponents. And then y to the 4th over y squared times 1 is y squared. Well, we got y to the 4th over y squared. I guess that'd be division. You could think of it in that term, because it is division. But remember, if you have y to a power over y to a power, you subtract a smaller exponent from a larger one. 4 minus 2 gives you a 2. And you have y to that power where your larger exponent was, which was on top. So we've got 18x to the 6, y squared over 1, which just gives us 18x to the 6, y squared. And that's our answer. Now typically on these, as they start getting more and more complex, I try to follow my order of operations so it gives the students a kind of a set way to do these. There's different ways to do them. Just as long as you're using a valid property, then there's probably really no wrong way. If you're making up your own properties, that's a different issue. And I think that's the end of that section. Yes, it is.